Okay, so this is our second video on confidence interval for two sample proportions, and we're going to go through this in a fairly rapid pace. So here we have 84% of a simple random sample of 125 nurses. So as soon as I see percent, I go percent's a proportion. So I'm working with proportions. So this is probably going to be some sort of proportion test. So 84% of a simple random sample of 125 nurses expressed job satisfaction working from 7 a.m. to 3 p.m., while 72% of a simple random sample of 150 nurses expressed satisfaction working from 11 to 7. Well, I have two random samples, right? I have two random samples. So that means I'm working with two groups. And in both cases, I have a proportion. So this would be p hat. This is also a p hat. So p hat 1 or p hat 2, excuse me. This is p hat 1. This tells me I'm probably working with the two proportion test or confidence interval or something. And it says establish a 90% confidence interval for the difference. Once again, we don't have to write the null and alternative, but we're trying to estimate what P1 minus P2 is. That's what we're trying to estimate. And if we were doing a null, P1 equals P2, and the reason I write this partially is because we know that all confidence intervals are two-tailed tests. So essentially, we're saying that they're looking for the difference, whether or not there is one or not. So P1 equals the true population proportion of satisfied nurses in the daytime shift. And P2 is the true population proportion of satisfied nurses in the nighttime shift. Conditions. Well, they told us we had a random sample for both of them, so thank you, that's taken care of. The next thing is the independence. And it's reasonable to assume that one shift's job satisfaction does not impact another's, and that makes sense as well. Truthfully, there could be an impact if one shift delays a mess for the other, but we're going to assume that job satisfaction is not impacted. N is less than 10% of the population for both. How do we know? Well, we assume that there are at least 1,250 nurses working daytime shifts and at least 1,500 working nighttime shifts. You can always do 150 times 10 and 125 times 10 if you prefer. Make sure you address both. Then we need to check our sample sizes to see if they're large enough. Well, in this case, we don't know what we have. So we need to look at our p hat. Well, our p hat 1 equals x1 over n1. Well, we know n1, our sample size is 125. So 125 times 0.84 gives us an x of 105. So 105 is greater than 10. So there's plenty of job satisfaction here. All right. Well, if we have 125, then we have that we can address q hat two different ways and find that x2. We can do it this way, where we go 1 minus the 0.84 and get 16%, and 0.16 equals x over our sample size of 125, and solve for x and get 20. Or we could just take one, or we could just sit there and take for this 125 minus the 105 is 10. Equals 20, and that's greater than 10. So that one's met. Over here, we had 72% job satisfaction. So x2 over 150 equals 0.72, and that's 108. And then if I take 150 minus 108, I end up getting 42. And so we have 42 that are dissatisfied at the night shift. Again, all four conditions must be met to meet our normality. This represents normality. So both samples are large enough to use the normal approximation. Please remember, we're having to use a normal approximation because we're working with proportions, and proportions are essentially something that falls in the binomial. So we write our formula down. P hat 1 minus p hat 2 plus or minus z star. Well, what's really nice here is they started off with percentages. So basically we're going to have 0.84 minus 0.72, because that's p hat 1 and p hat 2. And I'm going to run out of room, so I better do this on a separate sheet. 0.84 minus 0.72 plus or minus, we'll come back to z star in a moment, p hat 1, which is 0.84, p hat 2 is 0.16, our sample size was 125, plus or minus, or plus, excuse me, not plus or minus, and we had 72%, so 0.72 times 0.28 over the sample size of 150. Well, we need to get z star, and z star is going to be second vars, inverse norm, and we wanted a 90% confidence interval. So parenthesis 1 minus 0.90, close parenthesis, divided by 2. And we get 1.645. So this value is 1.645. So this right here is really good work shown. We're going to go ahead and run this test, stat test. And we scroll all the way down to letter B. Oops, stat test. Scroll all the way down to letter B. 2 proportion z interval. And our x1, well, they really didn't give us to us. We calculated it earlier, but I want to show you something on a calculator. 0.84 times 125. Make sure that's a whole number. It is in this case, we're good to go. Our sample size is 125. 0.72 times 150. Make sure that that's a whole number. If it's not, you're going to have to round them. So make sure that x1, n1, x2, and n2 are whole numbers. N2 is 150. And we have a sample size of 0.90. And we end up getting 0.0391 to 2009. All right. Let's see if I have room. I know I've already written this down, but let's see if I have room here to 0.84 minus 0.72 plus or minus 1.645, 0.84 times 0.16, 125 plus 0.72 times 0.28 over 150. Looks like everything kind of fit in there. So there's our interval. We notice that our interval is positive, doesn't contain any zeros. So this is a significant difference. And it tells us that the daytime shift has a larger, is significantly larger than the nighttime shift in happiness. So we are 90% confident that the true difference in population proportion between nurses satisfied with their jobs, day versus night, lies within this interval. And in repeated sampling, we expect that our method will capture this true population difference between a day and night 90% of the time. And finally, zero does not lie in the interval, and so the difference proportions is significant. So we know the difference is significant, and because the interval is positive, we know that there is a greater proportion of daytime shift nurses satisfied with their nighttime shifts than those satisfied with the nighttime shifts. Once again, just looking here, I know that there's a difference, but because it does not contain zero, it's a statistically significant difference. Okay, thank you for watching, and I will see you in the next video where we go to confidence intervals for 2 sample proportions. Look forward to seeing you then. Thank you.